So I'm going to talk about the prisoner's dilemma. So this is an example in game theory that seeks to explain why two individuals might not cooperate when it actually benefits both of them to cooperate. So we're going to use the example of Coke and Pepsi. So who here prefers Coke over Pepsi? And who here prefers Pepsi over Coke? Right, so it seems like most of you prefer Coke versus Pepsi. So your decision of favoring one or the other depends a lot on advertising. And both companies spend millions of dollars each year on advertising through marketing, TV commercials, and so forth. So we're going to try to understand why that's the case. So imagine that you're the CEO of either Coke or Pepsi, and it's a new year, and you're trying to decide whether or not you should run a marketing campaign for this quarter. So you're the CEO, but you don't know if the other company is going to run a marketing campaign. So the question is, what do you do? So to help us out, we can write it in the grid format, where we rate the profits of each company under one of the 4 different scenarios. So we can write, let's have Coke on the horizontal axis. And Coke can either do one of two things. It could either advertise or not advertise. Not advertise or advertise. And we can put Pepsi on the vertical axis. And Pepsi can also not advertise or advertise. Advertise or advertise. Right. So the square here represent what happens if Coke does not advertise and Pepsi does not advertise. And so let's say under this scenario, Coke would make, to say Coke would make $10 million for the year, and Pepsi will make $10 million this year. And we can say, all right, so if Coke advertises and Pepsi does not advertise, Coke will make more money because they advertise and Pepsi will lose out on some of the market. And we can say the vice versa. So if Pepsi advertised and Coke did not advertise, let's say Pepsi makes $12 million and Coke only makes $4 million. And then let's say if both companies advertise, they're going to make the same amount of money, but because advertising costs money, they're going to make less than the original $10 million. So let's say they make $6 million each. Right. So presented. Oh, thank you. So presented with this graph, if you're the CEO of Coke, you could be like, I don't know if Pepsi is going to advertise this year or not. But let's assume that Pepsi does not advertise. What should I do? So I look at this and I say, all right, so if I don't advertise, I get $10 million. If I advertise, I get $12 million. So it's in my favor if Pepsi advertises does not advertise to advertise. So I'm going to advertise in this particular case. And then if Pepsi does advertise, my options of not advertising and advertising, I'm going to get $4 or $6 million. So it's actually in my advantage to also advertise. So no matter what Pepsi does, Coke is going to advertise. And you can do the same thing for Pepsi. So if Coke does not advertise, it's in Pepsi's benefit to advertise. And if Coke does advertise, in this column here, it's in Pepsi's benefit to also advertise. So what we find is that both companies decide to advertise, and they end up in this box here, which is interesting because there's actually another box that would benefit both companies. Which one is that box? The first one, here, right? So we can call this box an optimal situation, but this one would be equilibrium. So this is just an interesting example of how two individuals who might actually benefit from cooperating both decide to not cooperate and end up with a worse result.